Now, what is y0? It's 0. So we can forget about that. Guess we don't really need the parentheses. All right, so that's what we have. All right, so we want v1y. And again, this is what's great. You know, again, once you have this written, you don't need to look at that anymore. Everything you need is right here. So we want v1y, so we have to take the square root of both sides. So v1y equals plus or minus square root v0y squared minus 2gy1. Now, plus or minus, v1y is this way, so we choose minus. So again, you have to make that choice. Okay, then we just plug it in. So minus square root, right, v0y, just look over there, 5.3 meters per second squared minus 2. Remember, g is positive, 9.8 meters per second squared. And then what's y1 is minus 40 meters. And then, I promise, if you do it, you will get minus 28.5 meters per second. Now, let's pretend this is a test question. The people who write test questions are not nice sometimes. So, you know, it's multiple choice. So I can imagine that one of the possible answers is minus 28.5 meters per second. You know, you just work this out and you see it and you get all excited. Yeah, I'm done. You're not done. This is only the y component of v1. You want v1, so you want the x component and the y component. Sneaky, right? Well, that's life. Okay, so first of all, we want to get the speed, then we want to get to the direction. So the speed is just the magnitude of v1. And that's v1x squared plus v1y squared, square root of. So again, v1x, just look over here. Where is it? 8.5. And then we just figured out v1y, 28.5. I don't care about the minus because I'm squaring it. I mean, I'll care about the minus in a minute when I get the angle. And I promise you, when you do that, you get 30 meters per second. Which seems reasonable, right? I mean, 28.5 plus squared plus that squared, you know, all right. Last thing is the direction. Now, it's going like this, okay? So, it's, you know, some angle like that. Now, let's choose this one. Again, the question, if this were a test question, they would say something like, what is the direction relative to the horizontal? I mean, they have to give it to you, you know, because you don't know if they want this or this, right? So they'll always make it clear. All right, so this is V, this is V1, and then again, we resolve into components. So this is V1x, and that's V1y. And as we learned the other day, theta is inverse tan opposite over adjacent. Opposite over adjacent. V1y over V1x. And I promise you, when you plug it in, you get 73.4 degrees. Okay, so this is your typical, you know, two-dimensional motion problem. So I would recommend you do it on your own. Try to do it without looking at the answer. All right, let's do another one. One more example. So everybody read that while I erase. Okay, a soccer player kicks the ball towards the net 29 meters away. The ball leaves her foot at a speed of 19 meters per second and an angle of 32 above the ground. Find the speed of the ball when the goalkeeper catches it. And it says that the goalkeeper is 29 meters from the soccer player. Okay, there's a couple things you want to assume here. We're assuming, they give us the angle above the ground. So we're assuming that the ball was on the ground when she kicked it. Okay? But we have no idea where the ball is when the goalkeeper catches it, right? Most likely it's not on the ground. It's going to be somewhere else. So that makes it kind of interesting. Now the hint is awesome. The answer is not 19 meters per second. Now think about it. I don't really need that. Well, whatever. So let's say that's where she kicks it. All right. If the goalkeeper caught it ground level, it would be the same speed, right? Because it's free fall. Well, it's not 19 meters per second. So that indicates that the goalkeeper did not catch it on the ground. Caught it somewhere else. So again, those little hints are nice. By the way, I hope you have the kinematic equations memorized by now. You really should. Okay, here we go. Let's draw the silly thing. Okay, so the regular old coordinate system. Here's the picture. So just like the last one, right? x0, y0, t0, v0x, v0y, and here's v0. Again, we have no idea where the goalkeeper catches it, so we just put a dot somewhere in the air. So x1, y1, t1, v1x, v1y. It's free fall, look, all that. Okay. Where do you want to put the origin? Well, I would put it here, right? So x0 equals y0 equals t0 equals a sub x equals 0, right? Because it's free fall. Okay, v0 is 19 meters per second. Theta is 32. Why do they like 32 so much? I don't know. v0x, v0 cosine, you get 16.1. v0y, you get with a sine, you get whatever that is, 10.1. All right, so we did everything here. Now we go over here. Oh boy. Okay, we know x1 is 29 meters. They give us that, right? Thankfully, they gave us that. 29, that's a 9. We have no idea what y1 is. We have no idea what t1 is. Okay, we know v1x has to be v0x because it's free fall, right? v1x is 16.1, v0x 16.1 meters per second. And, oh, this is like the other one. Golly, boring. So find the speed of the ball when she catches it. So we need to find v1y. Oh yeah, I know it's, okay, this is a good problem. Now, for most of the problems we've done so far, like the last one, the last one we needed v1y. We just immediately got to v1y and we were done with it. Well, most of the problems that you're going to come in contact with are not like that. Most of the ones, like this one. So we want v1y. Unfortunately, we don't have enough information to get v1y. We don't know the time. We don't know the distance. We don't have enough information. In other words, if you look at the three kinematic equations, we don't have enough information to use any of them. So what do? You scratch your head and think, right? Okay, so in order to solve this one, we have to get T1 first. Once we get T1, then we can get V1y. So this is kind of a two-part problem, and you should expect to see more of these two-part problems. Okay, so first thing we have to do, again, so we want to get V1y, right? So I'm telling my brain V1y, that's what I want. But I look at the kinematic equations and I don't have enough information. So then I realize, hey, look, I know V0x. I know the horizontal velocity. I also know the horizontal distance. Well, think about it. If you know the horizontal distance and the horizontal velocity, what else do you know? You know the time, right? You know the time. Okay, so I realize this is what I want. I can't get it. So then I realize, okay, fine. I'll get T1, and then I'll be able to get this. And again, piece of cake. X1 equals V1 x T1, right? Distance equals speed times time. There's no acceleration because it's horizontal motion. So that's something you really want to look for. If you have, like a horizontal velocity and a horizontal distance, you can figure out the time with hardly any work at all. So be aware of that. Okay, so x1 equals v1x t1. Therefore, t1 equals x1 over v1x. Okay, look over here. 29 meters, v1x, 16.1 meters per second, 1.8 seconds. Woohoo! All right, so now I have my my T1. Okay, now you look at your kinematic equations. So we want to get v1y. And we don't know y1, but we know t1. So, okay, we can't use this one, because this would mean we have to know y0 and y1. Can't use this one, because we have to know the final y. Oh, look at that, right? This is what we want, the final y velocity. We know the initial y velocity, we know the time. That's what's going to work. Okay, so v1y equals v0y minus g delta t. All right, okay, what is that? Well, okay, delta t is t1 minus t0, but as usual, but not always, so you got to be careful. I mean, sometimes we have a two-part problem, t0 will not be 0. You just got to be careful. But for this situation, t0 is 0, so we don't worry about it. So we just have that. Okay. Oh, this is wonderful. We don't have to hardly do anything. So we just say v0y, where is it? 10.1 minus 9.8 meters per second squared. And t1, 1.8 seconds. Notice the units, meters per second here. This second kills one of these seconds, so we get meters per second. So 10.1 minus this, and you get a minus 7.5 meters per second. Now, the fact that v1y is negative, what does that mean? Well, it means it's going down, right? If v1y would have been positive, it means it would have been going up, which is kind of hard to imagine. Okay? Right, now we want to get the speed, right? That's what it says, the speed. So we want v1 speed, magnitude, whatever you want to call it. So this is v0x squared plus, sorry, v1x, same thing, but whatever, plus v1y squared square root of. And it's just a speed, so I don't care about the plus or minus. And so v1x is, where'd it go? 16.1. And this is 7.5. Again, I don't care about the minus because I'm squaring it. And that comes out to be 17.8 meters per second. Okay? So, all right. Very good. So, there you go. So this was a tougher one because you had to get x1 before you could get what you really wanted. But that's what you're going to see a lot. All right, thank you very much.